Imagine stepping outside and staring toward the horizon. On the Earth, the land bends away, hiding distant landscapes behind the curve. But in a flat world, that curve wouldn't exist. The horizon wouldn't swallow ships or make planes sink from view. They'd simply fade smaller and smaller, disappearing into an endless sheet of land or ocean. That might sound convenient at first. You could stand on a mountain and see for hundreds of miles in every direction, with no curve blocking your view. Cities, coastlines, and peaks would stretch endlessly into sight. Navigation would completely change too. Today, compasses, maps, and GPS are designed for a globe. On a flat plane, those systems wouldn't make sense. Distances would feel warped, travel paths unpredictable, and the rules of direction would collapse. Even time itself would look different. On a spherical Earth, time zones exist because sunlight hits different parts of the curve at different moments. Flatten the planet, and that balance disappears. You wouldn't wake up to a glowing sunrise that eventually arcs overhead. Depending on where you lived, the sun might linger in strange angles or hover overhead in unnatural ways. But the strangest part isn't just what you'd see, it's what you'd feel. Right now, Earth's curve creates the sensation of a horizon that bends gently away. Without that curve, space would feel unnatural, like walking on a gigantic map. Land wouldn't cradle you. It would stretch cold and flat, with no end in sight. And yet, as unsettling as this flat world would look, the real danger wouldn't come from the view. It would come from the force that pins you to the ground, keeps the oceans in place, and makes life possible: gravity. On a flat Earth, gravity wouldn't work the way you think it does, and the consequences would be devastating. You don't usually think about gravity. It's just there, quietly holding you down, keeping the oceans from flying off into space, and making sure the air you breathe clings to the planet. But gravity only works the way it does because Earth is a sphere. Everything is pulled toward the center, no matter where you stand. That's why someone in Australia doesn't fall off into the sky, and why oceans wrap neatly around the globe. Flatten Earth, and that entire system falls apart. On a flat plane, gravity couldn't pull toward a single central point anymore. Instead, it would drag everything toward the middle of the disk. If you lived near the center, things might feel normal at first. You'd still feel weight pressing straight down. But the farther you walked toward the edges, the stranger it would get. Gravity wouldn't point down anymore. It would start to tug at an angle, pulling you sideways toward the center. Every step outward would feel like climbing uphill, even though the ground looked flat. Now picture what that does to the oceans. Instead of spreading evenly around the planet, water would flow and bulge toward the center of the disk. Coastlines near the edges would dry up, while the middle would drown under an impossible mountainous sea. Rivers would run the wrong direction, pouring inward instead of downhill. And it wouldn't stop at water. Air would shift too, pooling thickest in the center, leaving the edges thinner and harder to breathe. Buildings wouldn't stand straight, trees would lean, rivers would bend, and mountains would look crooked as gravity dragged everything slightly inward. Life near the edges of a flat Earth would be unbearable. Walking would feel heavier, water would vanish, and survival would be nearly impossible. Even if you somehow adapted, the entire balance of the planet would be destroyed. What's incredible is that this isn't speculation without foundation. Physicists have modeled what gravity would look like on a flat plane, and every result shows the same thing. It just doesn't work. A flat Earth can't keep its oceans, its air, or even you in place. And without stable gravity, the next problem becomes even bigger: the sun itself. Think about your day. The sun rises, climbs across the sky, and finally sinks below the horizon. That simple rhythm rules everything: sleep, work, seasons, food. But it only works because Earth is a sphere spinning steadily in space. On a flat Earth, that entire cycle collapses. If the planet were flat, the sun couldn't rise and set in the way you know. Light wouldn't spread evenly across the surface. Instead, vast regions would roast under endless daylight, while others froze in permanent darkness. There would be no gradual mornings, no sunsets, just a harsh divide between hot and cold zones. Imagine standing on one side of the world, where the sun never moved from the sky. Crops would shrivel, water would evaporate, and survival would become a fight against unrelenting heat. Then picture the other side, locked in eternal night, where plants would wither, temperatures would plunge, and life would struggle to exist at all. And seasons? Gone. On a spherical Earth, the tilt of the axis gives us summers and winters as sunlight shifts across the globe. But flatten it, and there's no tilt, no gradual change, just the same scorching or freezing conditions every single day. Agriculture would collapse, migration patterns would vanish. Even your body's natural rhythm, wired to daylight and darkness, would unravel. Some flat Earth ideas try to explain this away by suggesting the sun hovers like a spotlight, circling above the disk. But physics doesn't agree. Light doesn't bend neatly like that across flat space. Instead, shadows, time zones, and day lengths all prove the Earth curves beneath you. Without the rise and fall of the sun, life couldn't follow a steady beat. The flat world wouldn't just feel strange, it would erase the very rhythm that makes Earth livable. Right now, Earth's spin and curve create invisible engines that power your weather. Jet streams, trade winds, and ocean currents all form because the planet is round and rotating. They move heat from one place to another, balancing climates across the globe. But flatten Earth, and those engines stop working. Without a spinning sphere, the Coriolis effect, the force that bends winds and drives hurricanes, would vanish. Air wouldn't spiral into storms, it would just pile up chaotically. Some regions would drown under endless winds, while others would be trapped in heavy, stagnant air. Imagine a coastline where storms never move on, hammering the same spot with rain for months. Then imagine an inland desert where the air barely stirs, leaving it scorching by day and freezing at night. Oceans would break down too. On a round Earth, warm and cold currents flow like conveyor belts, carrying heat across thousands of miles. Those currents make Europe livable, keep the tropics from overheating, and shape monsoons in Asia. Flatten the planet and the conveyor belts snap. Coastal cities would swing between extremes, flooded one year, bone dry the next, with no stable cycle to rely on. Even rainfall would collapse into chaos. In some places, clouds would never form because air stopped rising. In others, storms would rage endlessly, fueled by trapped heat and unstable winds. Farming would become impossible. Forests would die. Grasslands would turn into dust. And the bigger picture? Without Earth's curved spin, the entire climate system loses balance. Global circulation, the great looping pattern that shares heat between equator and poles, depends on a round world. Remove that, and there's no way to stop heat from building endlessly at the center or cold from smothering the edges. The result isn't just uncomfortable weather. It's a world locked in extremes. You'd either live under relentless storms or in deadly silence, with no middle ground. And yet, as catastrophic as the weather becomes, there's an even deeper problem. For all the wild storms and broken seasons, the very idea of a flat Earth still collides with something more basic, the overwhelming proof that our planet is round. At this point, the flat Earth doesn't just sound uncomfortable, it sounds impossible. And that's because it is. Every piece of evidence we have, from the simplest observation to the most advanced technology, proves Earth is round. Even before satellites, sailors noticed that ships vanished bottom first as they crossed the horizon. The masts were the last thing you could see, not because they shrank, but because they dipped behind the curve. Travelers also saw new constellations appear as they moved farther south, something only a globe can explain. Now add modern science. Airplane flight paths don't follow straight lines on flat maps. They arc across the globe because it's the shortest route on a sphere. Communication satellites orbit around Earth, sending signals that wouldn't work if the surface were flat. And astronauts? They've taken thousands of photographs of the Earth from space, all showing the same spinning blue sphere. Flat Earth ideas try to twist around these facts, suggesting hidden walls of ice or magical spotlights in the sky. But none of those explanations stand up to physics. Oceans don't cling to a flat plane. Gravity doesn't pull sideways. The sun doesn't hover like a lamp. Every test, every experiment, every piece of evidence points in the same direction. Our planet curves. And that curve isn't just trivia, it's what makes life possible. Seasons exist because the globe tilts. Weather balances because air moves around a sphere. Oceans stay in place because gravity pulls toward the center. You wake up each day to a sunrise and sleep each night to a sunset because Earth spins smoothly beneath a curved horizon. So yes, imagining a flat Earth is a fascinating thought experiment, but it's not reality. Life as you know it, oceans, food, breathable air, only works because our world is round. And that's the truth that keeps you alive every single day.